So today's topic of discussion is resonance. Resonance is one of the most complicated things about organic chemistry, and you absolutely need it. The foundations are learned in Orgo 1, but it comes back again in Orgo 2. So in case you get lost and you're in an Orgo 2 class, always revisit this video. So what we're talking about today, like I said, is resonance. We do have 3 different parts. So with resonance, you have 3 different styles. So you can have one that has a carbocation, carboanion, and a radical. Each one is going to be treated differently. So first, we're going to start talking about the carbocation, but I just want to list out all the information about them so we can move forward easily. So carbocations are positive charges. Normally, you will see it denoted with a positive charge, fairly simplistic. We'll talk about the arrows and what type of arrows we're going to use a little bit later when we start doing more of the problems. Then we have our carboanion, which is a negative charge, or it can also present itself in a form of a lone pair. So that's what I wrote here. And then you also have a radical, which is 1 electron. So now to get started, when it comes to resonance, we're going to do the positive charge first. So the way that I phrase the way I say something, you may see it in a different way. So this video, you're going to have to use your best understanding to see how I'm going to structure it out for you. So I may say something like going towards something, but you may say it's going to. So like when it comes to definitions and stuff like that, that's going to be up to you and how you look at that. So let's go back. So we're going to deal with this structure right here. It clearly has a positive charge, which I wrote some notes over here, which will tell you how many arrows you need. So every time you have a positive charge, you will be using 1 arrow at a time. Then the type of arrow you need is going to be a full-headed arrow. Arrows are really important in organic chemistry. So you have your full-headed, your half-headed, your double arrows. You got to make sure you understand everything. So we're going to talk about moving these electrons using a full-headed arrow. So coming back to this, like I said, your arrows that you need is only 1. When you're doing resonance, I want you to think more so about taking snapshots. Sometimes we see in class how the instructors move things and you just kind of want to move everything so quickly, and it doesn't work that way. So you have to really pace yourself. So I call these snapshots. You know, like when you're taking a picture, you're like, you get ready and you're like, all right, 1, 2, 3. I want you to think about it in that same aspect. So wherever your charge is, that is where you start counting as your number 1. So this would be my 1. Then you have to worry about your 2 and 3. With resonance, we worry more so about the sp2 bond, which is your double bond. So that's going to be the electrons that you're going to be moving. So that means I'm looking at the double bond that's right here. So I automatically know this one is 2, but where would my number 3 be? This can't be number 3 because there's no actual double bond in between there. So it has to be on this side. So far, hopefully you understand this is the first snapshot we're looking at when we look at this problem. Then now we have to worry about our arrow movements. So again, we're using a full-headed arrow. These are going to be curved arrows. This is telling us where we're trying to move that sp2 bond to. So I like to do it this way. You'll always see me use like tons of colors. I tell all my students, I get them a clicky pen that has multiple colors. I would say when it comes to learning, don't use pencil, don't use pen. Literally, find you several colors. You don't want to be like coloring throughout when you're learning, but it definitely helps to retain the information. So when it comes to looking at the double bond, I look at it as like 2 actual electrons. So what's happening is you need to move this double bond towards that positive charge. So when I say towards it, that means I'm going to that area. Now, when I look at it, I also think about it like this. Technically, you have both of these dots, right? So When I am rotating, which one of these color markers am I picking up to actually move towards the actual positive charge? So if I think about it, I'm really picking up not my green one, but my red one to move this towards here so I can make a double bond now between 1 and 2. So now my new picture, which the arrows we use for resonance to move about pictures would be this one. So this would be our first resonance structure. Another way to think about it, for right now, later on I'm going to start to change those rules, but for this particular one, you would go from, like we said, 1, 2, 3, and then the charge landed on number 3, right? So I always think about, this is my term, I call it skip a fella. It sounds really funny, but if your charge starts here, you skip this fella, your charge will land here. So again, now that you have a new picture, go back to your same snapshot method. So literally, you're going to now label this as 1, this is 2, and then this one as 3, and then continue the cycle. Now, sometimes people are like, Kessie, how do I know when to stop doing resonance? Well, sometimes if you look at your structure, if you have your double bonds in a consecutive order, and what I mean by that is double, single, double, single, double, the amount of double bonds in your structure may tell you how many different pictures you'll get. So in this case, you'll get 3 different structures. Go ahead and try and tell me what you get. So I'll continue for you. I still use the skip-a-filla method. 1, skip, here. It works. There will be times where it doesn't work, but I will let you know those instances. But you see, every time I just take my time, I go through, sorry, I didn't use the red marker over there. So then I would have this structure. Yes, oops, forgot that one. Now, if I kept on going and I made this my 1, 2, 3, again, these are my 3 structures that I get. Notice this right here. Your very last structure ends up being very similar to the starting one, except you have moved or delocalized all your double bonds inside the actual ring. If you have more questions, I'll be doing more problem solving a little bit later, but this is your foundation for carbocations.